Okay, Monday, lab 6. And just so I don't, okay, that's enabled. Just wanted to check whether to, oh, one more thing I should remember to do. Wait a minute, I'm host, right?
Yes.
Okay, I'm looking at,
Actually, I am the host. So let
oh, that's
me
why. Can you make some
let
breakout
me.
rooms? I think actually you'd be like the breakout room manager, and then yeah,
Okay, so
then I can share the screen.
let participants choose room. I will create just a couple.
Hmm. And open up lab 6. Here it is.
I'm gonna go into a breakout room for a moment, so I'll let you handle this for a while.
Okay. Okay, let me see. Shoot, let me switch to single mode. Let's do this. The breakout thing is covering it. All right, where are we? Is the dark mode okay with people? I can change it to light mode if it's like making it hard to see or anything. Okay, so I'm not sure which ones of these are super tricky. I mean, the thing about this lab is, I mean, it's only, first of all, it's only 3 questions. And it's less coding so much as like following directions, following, like, it's like a cookbook, basically. Like, literally, this first problem is you guys going into the plot documentation on the MATLAB website. And then, I mean, there's a little bit of coding regarding like this polynomial stuff and like figuring out how to do this part. But for the most part, it's, I mean, let's go to the second page, right? This is the details. All of this stuff you guys do. And instructions on how to do this, like for the most part at least, is on, you like literally go on the MATLAB documentation and then look up plot. And then search this up, search up like MATLAB plot, literally Google that or whatever search engine you use. And then it's like this big old documentation page. And it'll say, how do you change the marker type? How do you change the line thickness? How do you make a legend? Okay, legend I think is a different one. It's like, oh yeah, I think it's on the same page. I haven't checked, but you literally just type legend, and then that should be it. Location of legend, grid lines. It's a lot of details, but all of them fall under the umbrella of plot. And feel free to correct me if there's anything that's not under plot. I'm pretty sure. Yeah, title, X label. Hold on, let me get this out. There's things like X label, Y label, title. And then these will be like functions, and you like plug in a certain string with whatever you want that X label, Y label, and title to be. And then over here, there's things that go under something called line spec, which is, it's not, well, it'll say line spec, but basically what you do here is you have your plot, and you'll have like X, comma, Y, comma, and then you'll have like some string. There's one that's like color, comma, and then you can pick either, say, put a string next to it saying blue, or you can put like an RGB value, whichever one you prefer. And I think for this one, you'll just use like red or blue, like red lines versus blue lines for even versus odd polynomials. And then there's other ones, line width, there's a bunch of them. I mean, you can like, MATLAB has a lot of different options for how you want to plot how you want to make your plot work. But like, I'm not even going to go over all of these. I think it's all in the documentation. So, I mean, that's your reference. So let me know if you guys have trouble accessing that or reading that. Yeah, Control F if you want to. Let's see. Clear this. Okay. scroll down and see if I missed anything. So just another overview of what this problem is. You have some function. This is a little bit of coding as well. And you'll have some x's, maybe like this will just be like plugging in linspace, -1, 1, 2000 or whatever. Probably not 2000, probably some smaller numbers so you can actually see the markers. And then you have the maximum order of the polynomial. So I mean, in this case, if we had just use an example, this might be, I can maybe illustrate what this big old function is trying to do. Let's do what I like to do and say plug in some number. Let's say 2 for n max. So this is a quadratic. We're having a f of x, and that's 1 over n. So what is this going to be? So order n polynomial, that means this is going to be 1/2. 1/2 times x minus 1, ... all the way until this is basically saying x minus n minus 1. So -1, 2, all the way to n minus 1. And here's a trick that might help you with coding. This is the same as x minus 0. So I'll spoil a little bit of it, but 0, 1, 2, 3. Think of this as a for loop. Loop from loop from 1 to some number. That some number is going to be n. Or if you just want to go straight to 0 to n minus 1, you do 0 to n minus 1. That's my hint to you. But in this case, right, we'll start at 0. We'll go all the way to n minus 1. And n is 2, so 2 minus 1 is going to be the last term. Okay, so we just have this. And that's a quadratic, right? X times x minus 1. Yeah. And that's our f of x for order 2. So we have our f of x, which is basically our y. And that's just going to be what our plot's going to look like. So let's say this is our plot. I'm not sure what this looks like, but it's some sort of upward-facing parabola, like that. And maybe it's centered somewhere else other than the origin. I'm not going to take the, I'm lazy. But that's the idea. And then you'll increase that for order 3, like order 3, that could be like 1/3 x, x minus 1, x minus 2. And then you'll continue that pattern. 1/4 x, x minus 1, x minus 2, x minus 3. Okay, erase this in 5, 4, 3, 2, 1. Okay, I see the chat. Sample output. So sample output, I'm not sure what you mean by that. Oh, I have it annotated.
Sorry, it's just that for the sample output in the PDF, it looks like order 1 is just x squared and just x instead of 1/2 x times x minus 1 and 1/2 x essentially.
So the line's order 1, and then the parabola's order 2, and then. Okay, repeat your question.
Okay, yeah, this is just a bit confusing to me because this looks just like x squared and just x essentially, not x like 1/2 x times x minus 1 or whatever the function, the given function predicts.
Well, we know that 1/2 x times x minus 1 is an upward-facing parabola, so that checks out.
Yeah.
Okay, so what is this? If this were like 1/2, let's start from x squared actually. So let's do some transformations. X squared. What happens when we go from x squared to 1/2 x squared?
Well, it's just it's a flatter parabola.
Okay, and then I want to do this. I mean, if we factor this, we already know the roots, right? I mean, if we want to say, oh, where does this equal 0? So it's like 1/2 x squared, right? This has like 2 roots ish, but they're both 0. in this case, what are the roots?
Oh geez, wait. I just saw the crap. I just saw the endpoints of the thing. Sorry for interrupting.
Oh,
your-
like
your-
these ones?
Yeah.
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 It doesn't look too different from like 1/2 x squared, just because like this just how we're going from -20 to 20. So I
Yeah.
mean, moving it this little bit downward is not going to make much.
Yeah, of course. But it's like but for order 1, it just looks like a plot of x. Just f of x equals x, not 1/2 x or whatever.
Yeah, it just looks similar, but I mean,
Okay. Yeah.
1/2 x versus x.
Oh wait, if it's order 1, then it's just 1/1. Lol.
Sorry. Oh wait, yeah. That is x. Yeah, sorry.
Okay.
1/1.
Okay, I just misinterpreted the all right, cool. Great.
Yeah.
I was just looking at the graph and thought, wait, that doesn't seem like the function. Anyways.
fx. Nope. Wait, not like that. So let's see. The first view of these should be like x, then 1/2 x minus 1, 1/3. Okay, yeah, that makes sense. And then x minus 2.
All right, gotcha. I was doing it last night and I just made x squared, x cubed, etc.
Yeah, you gotta use the function.
Yep, okay.
Okay. I'll stop for some other questions on this one. If not, I think this one's pretty straightforward, just a lot of checking boxes. Okay, well, there's 1.2 as well. Okay. Going once, going twice on 1.1. Going once, going twice. Okay, moving on to 1.2. And feel free to interrupt me at any point if suddenly a question pops into your mind. Plotting surfaces. Surface plot. We're moving into the third dimension. All right. So it looks like we're already given the. Let's see. Wait, what's the wave number? Okay, that's probably down here. Yeah, I'm assuming you guys don't need to know like the physics behind any of these problems, by the way, since they already give you the functions. So we'll just work with what information they give you. So one-dimensional wave patterns, I assume they mean like ocean waves, and we'll plot them on like a 2D grid. Oh, I can't do that. Oh, I see what's going on here. There's like annotate in the actual PDF, and there's annotate in the. There we go. Okay, we have an X and we have a Y. And what do we do? So at every single X and every single Y, we have like a wave. So it'll be like this, waves on an ocean. It'll have some elevation. Now I'm sure this is an actual ocean wave or like a wave in space. What just happened? Okay, my PDF took a dump. Let me open that up. Okay, we're back online. Sorry about that. Yeah. Okay, I see it now. So here are your inputs. So no matter what your inputs are, your function's always going to have this form. 1/2 of sine of some number times x, 1/2 sine of ky times y. So that, okay, looks like they simplify it further actually. If I remember correctly, I mean, I think they'll probably say it on the next page, but yeah, you'll need to use something called mesh grid. And this is, you may have seen this during lecture, but what this essentially does is it allows you to get all possible ordered pairs. Like it basically generates a matrix. Well, not basically, that's literally what it does. 1, 2, 3, and then 1, 2, 3. Let's say these are your x, these are your y. So you'll put this into something called mesh grid. What does mesh grid do? So here's what it's going to look like. You'll have like an x, x, and a y, y. I might be misremembering the terminology for like the actual names of these, but what these are going to look like is this. So your x's are going to be like x, y. I believe it's 1, 1, 1, 2, 2, 2, 3, 3, 3. And then the y is going to be the opposite. 1, 1, 1, 1, 2, 2, 2, 3, 3, 3. So wherever you have an element, let's say your first element, that's going to correspond to 1, 1. Like here's your XX, Y, Y. And then you go to the next element, 1, 2, 1, 3, and each of these is an ordered pair. So it'll basically turn into stuff like this. 1, 2, 1, 3. And then you'll plot your function at each of these ordered pairs. Your f of x, y, or I'll be more specific. F of 1, 1, f of 1, 2, f of 1, 3. And the f in question is given on the previous page. Just a multiplication of two different sign values. All right, let me scroll down a little bit. Again, this is all, you can probably find this on the documentation. And I mean, it's very cookbooky, cookbooky. Just checking a lot of boxes and making sure that you have things like the range, the resolutions, the element by element. Why are they saying this warning? All right, let's take a look back at the function for a moment. I'll clear this in 3, 2, 1. Let's go to the previous page. When we do this, let's use this function down here, number 3. We'll have a matrix of x's. 1, 1, 1, 2, 2, 2, 3, 3, 3. Or more simply, 1, 1, 2, 2. Let's keep it simple. We'll do a sine of this one. And this is going to end up being, well, it's going to be sine of 1, sine of 1, sine of 2, and sine of 2. So what they're saying on the next page, right? Difference between matrix multiplication and element-wise multiplication is we're going to have another matrix that comes out of here. Sine of 1, sine of 1, sine of 2, and sine of 2. And we'll want to make sure this is element-wise so that they correspond to the same ordered pairs. We want 1, 1, 1 to be in the same place, 1, 2, 2, 2, 1, 2, 2. So make sure we do that so that we don't get any weird results. Because if we multiply it ordinarily using matrix multiplication, we will get the same, the correct size, but our numbers will be messed up. And we don't want that. Okay, clearing in 3, 2, 1. Surf C to actually make the plot. Okay, there's a little bit of subplots. So you'll have the surface of 2 and on. Oh, I see. So oh, my mistake. So these are two different functions actually. So somewhere in mind I was thinking this is like some sort of identity. But you'll want to plot both of these on the same plot. So you'll have a subplot on the left and subplot on the right. And there's documentation on that as well. And okay, for this one, I'll need to actually like check what that is, but it's going to be subplot, and there's going to be, I believe one of them's an array, and you specify like what size it is, like 1, 2, and then no, let me check this one. Give me like 5 seconds. Okay, subplot. What's the? Oh, I see something in the chat. You'll get lab answers. I think I want to go over some of the conceptual stuff first, and then we'll move into that. I think what we can cover 2 out of 3, but I think okay, after I go through the code, it's probably best if I ask people what they think is tricky. I think these are like different levels of straightforward, but some may be more tricky than others. So I think this might actually be a good week for us to just kind of go through the documentation together and like see how to do that. The 3 is confusing. Okay, we might just get straight to the solution for number 3 then. We'll see how like what that is trying to do. Okay, subplot, found it. Okay, it's not an array. Okay, I made a mistake. What this is actually going to look like, the syntax for subplot, is it's going to be 3 things. Say we have 2, 1, 1. So what that's going to do is, here's our figure. It's not going to look exactly like this, but the idea is you have, this is like the subplot position. So our plot. And then this is the size of, you can kind of think of this as an array of sorts, but it's an array with like 2 rows in 1 column. And then if we specify 1, that's going to go in this box. And if we specify 2, it's going to be in this box. We can change this to 2, and then we'll have a 2 by 2. 2, 2. And this corresponds to subplot 2, 2. And if you want to place it in, say, position 3, 1, 2, I believe this is 3 over here for linear indexing. And all that's done under the documentation. Okay. Did and I could go through the nitty-gritty of all of these, and I think it would be a better use of our time to kind of. So first I'll do this. I'll go through 2, kind of speed through that, and then we'll go to the solution for 3. And if people, I mean, which is worse, 1 or 2? We'll do whichever is the trickier one of those next. So this is, okay, it's extracting data from a text file. Variable header. See documentation. It could just be me, but this doesn't look too bad. I'm thinking we'll do 1 if anyone doesn't have objections to that. But we'll go 3 and then 1 tentatively, because 1 has a lot of like not moving parts, but just parts. Okay, so let me stop the share for the PDF. Let's just go straight to the MATLAB for this one. So give me like 15 seconds to pull it up. Okay, let's. Subplots. And it's called my subplots. Okay. And conceptually over 2. Sure. We'll go over 2 and then maybe the solution to 1 after that. Okay. Where is it? Share screen? Here it is. Okay. This one, what's this one? Okay, let's see what's going on over here. So what functions are we looking at? fopen, string to num, grab data, headers. So there's a lot of like new functions, it looks like. Unless some of these are. Oh, grab data. Okay, that's thought that sounded weird. So that's a sub function.
No, headers is a
grab data, I
cell.
mean.
Yeah.
But what were you saying about headers?
No, headers is a cell containing the the names, the strings.
Okay. Well, you use string and num, so I think, let's see, fopen, you guys, I think this is new. Okay, what else are we doing here? Henry Tang. I might know him, actually. Oh, never mind. Okay, let's see what they're trying to do here. Coordinate grid, Z coordinate grid, TW matrices. Okay, let's give this one. Okay, haven't looked at this yet, but let's just see what's happening here. So this is an XZ data, I believe. So XZ data. Now, I'll be cross-referencing the PDF while I'm doing this. So this is going to be a 1x(n) cell array with file names to be plotted. Okay, so I assume it has n file names. And actually, can we stop this actually? I think we'll just go over the PDF first, and then we'll kind of go to the solution, just so that, because I need to orient myself as well. So it's still going to be a plot. It's just, we're going to use some data from the XZ data, and I believe that's been posted to B courses already. Blah, 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 some conceptual stuff. Three-dimensional velocity and temperature, and this is all data in the files they provide to you. Horizontal resolutions. So they give a format that we'll need to be aware of. Give the spacing between each point. Yeah. So it gives the spacing, it gives number of points in the X, in X, number of points in Z times the slice. Okay, so this is going to be XZ data, and it's going to be a matrix of X's and Z's. I'll write it like this, and it's taken at some time. And then if you take a different time, it'll have a different slice and different XZ values. Or, well, no, not different XZ values, different, whatever values are up here, temperature, three-dimensional velocity, that kind of thing. X direction, okay. There's a lot of moving parts. Okay, here's the actual part that we need to code. Array of file names, and each of these is a point in time. And I believe it's like every hour. I want to make sure that. Labs 6. Yeah. 9 o'clock, 10 o'clock, and it covers like a 9-hour span. No, wait, hold on. 25, 100. There's like 25 and then there's 100. Okay, so it's just hourly. And plot them in chronological order. So you're plotting temperature and velocity over time. And that's my understanding of it. It's a lot of words just to basically say that. Okay. And I feel like I should be saying more about this, but it's not as much coding as just following these details and then making sure you cover all the bullet points. Like I feel dumb kind of going through this just because it's like it's not so much it's not coding. It's following these details and making sure that we have all the. And I'm repeating myself. Let's just go to the solution. So we have these file names. So we want to first of all know how many total files we have. And I think what they're doing here is they're having like the number of files is, so you'll have stuff like this where you'll have like xz something something 250900, and then this part will be the same, and then you'll do that until like say, what's the last one, 1500, and then it'll be like 1 hour chunks. Like this is military time, 1000, 1200, I can't count, 1100, 1200, you get the idea. And you'll want to count how many of those there are. So that I think there's 6, right? No, that would be 7 because we need to include the ends. Anyway, this is going to be 7 for this example. And then for 1 to 7, you'll want to do, first of all, open them up, and then, okay, what are they trying to do here?
So each of those files, Dennis, each of those files will have a set of headers in the first line. So that's what they're doing in line 9. They're extracting the headers and putting them into the cell named headers.
Mm. Thanks, Jose. I'm not sure how confident I feel going through this. Like, I can just show you this, but a lot of this I haven't seen before myself. Jose, are you okay with this?
I am mildly familiar. I read the PDF, but I haven't gone through the solution myself. But if you open one of the TXT files, you'll see what I mean. The first line corresponds to the. Oh, you stop sharing.
This one.
Yeah. So the first line corresponds to so this means that this file contains 799 number of points in the X direction, 63 in the Z direction. So that's like a grid. And The 0900, I think, is the time, the specific time at which these points were taken, and the last, yeah, the last one is the dx, which is the let me check. I forgot
like
what the
the-
last one meant. Is it spacing?
Yeah.
Yeah,
and
it's spacing between each point in the x direction.
so why are some of these negative then?
No. So the first line, they are
Oh.
not headers of the columns below. They are just like metadata.
Oh yeah.
So the columns below don't represent that. The columns below represent the velocities in the 3D velocities in x, y, and z. Let me see. Sorry, the first column is the z values, the z coordinates. The second is the x velocity, y velocity, and z velocity. And the last one is the temperature.
Mhm.
So
All these are the same. Oh no, they're not. Okay.
yeah, no, those are the points in the grid at that particular time at the 0900, which I think corresponds to 9 a.m.
Yeah, this is one slice. It's a lot of numbers, but it's one slice at 0900 hours, 9 o'clock in the morning. So all of these are at the same
time period.
Okay, it's the same time, and all of these, oh, well, it's still going.
Yeah, there are 799 points
Per, and this is our temperature. No, this is our Z.
Yeah, so as I understand it, these will go through a grid of the 800 points in X and elevation Z1. Then it'll start going through the same points in X at elevation Z2, then elevation Z3, all the way to elevation Z63. So this must be 800 times 60 points, roughly 24,000 points. Am I doing my math correctly? Am I adding a zero there?
Why is, so this is the same Z at the same time. So do the,
But
am I right?
but at 800 x's.
Okay, so each of these corresponds to one different X.
Yes, exactly.
Okay, that makes sense.
Yeah, so this corresponds to a grid of roughly 24,000 points.
Okay. Makes sense to me. And that's why they're using reshape to kind of make this into a matrix.
Yeah, exactly. So this is an interesting problem in the sense that it resembles the way you actually use MATLAB to process data from. Somebody will hand you data in whatever format, and you need to gather it, to understand it first, and then gather it, load it into MATLAB, and reshape it such that it's useful to you. So we were on line 9, I think, and on line 9, what they are doing is extracting the fgetL. So what they do is in line 8, they open the file in the sense that it is accessible to MATLAB. MATLAB can read what's in that file. It's like loading the file into MATLAB. Not exactly, but it works kind of like that. And this is that fopen. That's a cool function because it lets you, if you go into the documentation, that function also lets you, for example, if you have a txt with a bunch of points like the one we were looking at, and you're using MATLAB to collect new points, you can grab an old txt and append new points as you gather them. So you can add information to the file using this function. You can also rewrite the file completely. You could pick a line of a particular line of that file and rewrite it programmatically. And by that I mean run a program, gather some output, and put it into a txt file, overriding a specific portion of it. So it's a very cool function. You should go through the documentation. But here what it does is loading it into MATLAB, and it assigns a file ID to that function. And when you call fgetL, that function in line 9, that means get line of this file. So you have to pass a file ID to fgetL. And what that line does is gather the first line of the TXTs and convert them into numbers, because in the TXT, if you just load them and get that line, it'll understand it as the text that says 799 space, what was the other number, 63 space, and all the rest. And you actually care about the numbers, not a piece of text that says the numbers. So perhaps we could go into the documentation of fgetL, Dennis, in case they're not familiar with this.
Sure. Where are, oh, here it is. This one, right?
Yeah. So I've actually, I'm not, honestly, I'm not so familiar with this function. So I also want to go through the documentation. I learned about its existence only a few weeks ago, and I've been using it ever since. But so read line from file, removing new line characters, and it gives an example here. They open that poem.txt. They use fgetL to that file. So look at the example they use here. File ID equals fopen of that file. So they get a file ID. That's the input that fgetL needs. And what it gives out is the first line, oranges and lemons, and that's it. I think there's a way to get new lines. Successively, it starts getting the next line, but I'm not sure about that. There's an example above this.
What are you trying to do?
I think that if you call fgetL a second time, it'll get the second line, but I'm not 100% sure about that.
Want to try that?
Sorry?
We could just try running the tester and then see what that does. Okay, hold on, let's see. What do they do in the tester? Oh, let's see. Share screen and go to MATLAB. So the tester for lab 6. 109. Okay. So this is what they have as, let's see. Okay, it's a 1x2 that they provide. So if we run, hold on a second, let me put the solution for this into the current folder, and then we'll be ready to go. Subplots. No, that didn't work. Okay. We'll rename this my subplots. Oh, .m. There we go. Okay, so we'll open this up. Now, if we want to run my subplots, we'll just go here. And then run that. Oh, one more thing. Put a breakpoint there. Let's step through these functions. Okay, we're in the code. So we have n files equals 2, so that's the length of the file names. We have 2 things inside this cell, 2 file names. And for 1 to 2, so this is the first file name that we get. It's file ID 3. And then we'll keep stepping. Let's see what headers is. Okay, I think that it'll be better if I just open this up and then see. Since the cell array, we have to do the curly brackets. Okay. So this is the NX, NZ time and the DX. Okay. So now that we have the headers, go ahead, yeah.
So just so that you have this tool in your toolbox, the fgetl, I don't remember. Could you run it once more? Fgetl file ID. I want to see if it gets the second line, because there's a way to do that. I don't remember which way it was.
Okay, so I think I'll just simply
out of curiosity.
And then run.
Yeah. So every time you call fgetl, it gets the next line from whatever it got before. So just as a comment for you to have that tool at your disposal.
Never do that. Okay, next line. What are we trying to do? ZU. See. Okay, grab. Oh, that's down here. Hold on.
The grab data, is it a subfunction? I think it's a subfunction.
Yeah. Let's go through that as well. Okay, breakpoint. Continue. Okay, we're in this subfunction. Given the file ID 3, initialize an empty data. And next, okay, so next is the just next line.
Okay. But by the way, out of my curiosity, we might have messed up this test, because now it will get line 4 and onwards. It will skip the first few lines.
Have we? Let me check that. This is actually the first line.
Let's see. Maybe.
fgetl. I want to check to make sure this is actually the next line. Give me 1 second to check that. So what file is this?
Oh no, actually, look at it's the first one of the fgetls that you called. It's the first one, so it probably forgot when it went into the subfunction. Maybe.
Happens. Okay. Works for me. Okay, where are we? fgetl of 3, and that gives us the next line of that text file. So while next is not equal to -1 from the documentation. Okay, next one, -1 basically means we've reached the end of the document. So data, okay, this structure we have seen before. Initialize, and then we add data, add something, in this case, a double to this data array. And it's going to, so because there's a semicolon here, it's going to add another row every time every time you run this while loop. And then next is just going to be what we did before, which is getting the next line of that file. So I don't want to go through this entire while loop, so continue. Okay, it's a good thing we didn't go through that entire while loop because look at the data on the left. Actually, let's just look at it. Let's open this up. Oh dear. Oh, that's what, by 5, right?
Which, by the way, that's a useful thing to remember when you are debugging. You gotta know how to skip loops. Just as Dennis did right here, you put a breakpoint after the loop and click continue because you cannot go through all the probably thousands of loops that the program will make.
So here's where you assign each of those columns, first column, second column, fourth column, and fifth column to their own little array or row vector. No, column vector. And then, okay, F closes what kind of stops the process and stops us from, actually, what does this do?
So you open the file, kind of loading it into MATLAB, and Fclose does the opposite. It closes the file, so it cannot be edited by accident, or you're calling the wrong file by accident. And I also think it's a matter of memory. So it's a good practice that whenever you stop using a file, you close it in MATLAB.
Cool. Do we have a breakpoint in place? Let's just step to the end. Okay. Now that we're done with that one. And then now we use the headers, NX, DX, and Z. And I don't know why these are in, okay, because they wanted to have the X in the same. Either going to be 25 or 100. Okay, that's what the 100 means. I was wondering about that. Because in the file names, they have like either 25 or 100, and each of those is going to correspond to the DX. Okay.
Oh, that's interesting. I didn't know that.
And here's onto the actual generation of the X and the Z. I assume we're going to mesh grid these together. So for each file, and oh, here's another. We're going to put them all into a cell array. What is this trying to do?
So remember, we only had the Z's for different X's, which we don't really know. So these creates the X's from 0 to however multiple of the X's.
Oh, okay, that makes sense. So NX, what is this? So for this one, we have NX of 199. So this is going to be 0 to, okay. You know what? Instead of actually piecing this together, let's just do this. No, continue. Hold on, what just, oh, I see.
I went into the subfunction again. Yeah.
There we go. Okay. Now we're here. Now let's see what this X real becomes. So X real, where is that? Let's take a look. X real of, wait, what? Oh, underscore.
Yeah.
And it's going to be a row vector?
Yeah,
right?
so probably it will be better to open it through the editor. I mean the workspace for visualization. And yes, it's a 1 by 199, and it's just adding DX 199 times to 0.
Okay. Seems pretty cool. Xplot. What's this supposed to be? Let's take a look.
So this seems like an artificial mesh grid.
Oh yeah, that does. Let's oh, where do we want to put this? Let's do here and continue. Xplot Of course. Let's just do it through here.
Oh, actually, it doesn't do what I thought it was.
I'm not sure why that is. Because they seem like the same thing.
Let's go back to the code. I thought it was concatenating them. Oh, I think it is. This is the first iteration. So if you step again. Yeah, it is concatenating them. So remember, let me annotate the screen just for a second. Annotate. So remember that in the txt file we had one column of z1, z1, z1 for all the x's, and then we started z2, z2 for all the x's. So this corresponds to x1, x2, all the way to x number of x's, and then again x1, x2, all the way to x number of x's. And this in the txt file goes all the way to z number of z's, z number of z's, z number of z's, and these points correspond to x1, x2, x number of x's, and on the second column we had the velocities in x. Wait, what was the second column? It might be, no, it was velocities in x, right? Vy, vz, and temperature. So that was the structure of our txt, so of our data. So what this thing is doing, the first one, the x real, gathers our set of x's. So 0 through dx all the way to number of x's minus 1 times dx. Let me see, there was something like this here. Yeah, this guy. And the second line, or this loop here, is concatenating this guy here corresponds to the first z, this guy corresponds to the second z, third z, all the way through the last z. So it's concatenating that vector in z times.
I believe what they're doing is they're literally doing what MeshGrid does. Am I wrong?
I also believe they are doing what MeshGrid does. So I think this is like doing a MeshGrid and then no, it's exactly like MeshGrid does. I'm not sure why they didn't go with MeshGrid, but yeah, that's the whole thing. They are going in lines through. They're doing in lines 18 through 23.
And 63 is the NZ, right?
That is correct. Yes.
So it's going to be a matrix that's 199.
Oh, is it a matrix? Oh, yes, because they're. Oh, I thought these are row vectors. You're right. I thought this would be a really, really long vector.
Yeah. It'll be like this. So this is our XX, and then the next one's going to be like our XZ, and that should also be our the same size. Yeah, they're like putting a bunch of columns next to each other 199 times. Oh yeah, all right, I get what this is
All right.
what this is doing.
So
thanks for that, Jose.
I can clear the screen. I'm not sure if anyone wants to take a screenshot of this mess, but I'm gonna give 5 seconds. So 5, 4, 3, 2, 1. I'm gonna clear all
drawings. And dot 1000. So why is this here? I assume
it's for units.
Okay.
I think the PDF says something about using kilometers, turning kilometers into meters. Let me check.
That makes sense. I'm not sure you need a ./1000.
Because it's a scalar, yeah. it's a scalar. It doesn't really need the dot, but it works.
Henry works in strange ways. And I might be wrong, but I think I like knew this guy before he graduated. He's an interesting guy. Or he just like has a similar name, and I'm just completely butchering that. Okay, what are we doing here? Here they're using reshape.
I'm gonna be right back at just a second.
Okay. Let's continue and see what they're doing here. Oh, I see something in chat. 40 to 45. So let's see what the reshape is doing. I can like skip through this. Okay. So for 110 files, so for each of the 2 different text files we were given, what's it going to do? So it reshapes. So what this essentially does is it takes the T we had before, and let's just review what that is. So it's a big column vector. We kind of saw that in the text file, and I forget which column it was, but we've extracted it and we've assigned it to T1 because we're in the first iteration of the for loop. And we're going to have this as a matrix that's this many rows and this many columns. So let's make sure nx1 199, okay, nz1 63, 199 rows and 63 columns. So let's just check. And that's going to be, because of the transpose, they're going to turn this into a 199 by 63, and then they're going to transpose it and make it a 63 by 199. All right, well, let's see what this does. So tplot. I'll take a look at the chat in a moment. Yep, 63 by 199. Yeah, apostrophe means transpose. So if we had 1, 2, and then we did 1, 2 transpose, it's like that. We do it with matrices as well. Same deal for U and W. You take these big, long column vectors that from the text file, and then we reshape them into something like this. And that should be the same size as whatever our X and our Z are. Otherwise, it'll return an error. Like, I'm not sure what that error says exactly, but it's like your whatever is the wrong size. And once again, I don't want to go through all this. I think it's only 2 loops, but okay, finally we're at the plot part. Finally made it to the end. We have a figure, and then n files, in this case 2. We're going to have a subplot that plots all of the different plots in the same figure. Should we skip to the end here? I'll definitely place one here. dx equals 25. Here's what this does. We only have 2 possible different dx's in our files. It's either 25 or 100. Basically, this is 100. And then, what are they doing here? Looks like this is the spacing for. This is our x velocity, I believe, and this is our. Hold on, what are they using this for? Oh yeah, here it is. X plot. Okay, they're taking the X plot, which is that big, the cell array containing matrix. But let's just open this up. Cell array containing 63 by 199 matrices, and this is going to be what we talked about before. A bunch of different a bunch of different row vectors laid out on top of each other. And we're going to index that matrix why do I need to do this?
I'm a little bit lost here. A quiver is where did we define quiver? Or is it a function? No, it's not a function.
I'm pretty sure that has to be a function. We didn't define it anywhere. I don't think so. Quiver. Oh, it is. Let me stop share for just a moment. 3, 2, 1. Interesting. What are they doing here? It's a vector plot, and that looks like, oh, it's a slope field.
That is a cool function. I did not know of this function.
So you have your x's and you have your y's. Each of these is like your mesh grid-esque coordinates, and this is going to be the slope in that direction. So bigger arrows correspond to bigger values of u and v, to my understanding. Air current over North America. Okay, I sense a common theme with this.
Yeah, it seems to be x, y, velocity x, velocity y, and the magnitude of the vector velocity x and y determines the size of the arrow. That's a really cool function. I didn't know about this.
Oh, okay, this is a cool one.
That being said, I have heard many people have the feeling after looking at these solutions of how could I possibly have thought of this solution in particular because I was doing something completely different. I myself would have done something completely different in this problem to what we're showing on the solution. So if this doesn't resemble what you've done so far, don't throw it to the garbage. Like, it doesn't mean that what you've done so far is wrong by any means. This is one way of doing it.
Yeah, well said. Contour F, here's how we create our contour plot. We have our x and z coordinates. Both of these are matrices. And then this is a t-plot that's the same size. So, 63 by 199, 63 by 199, same deal. Now let's put a breakpoint here. Let's see what happens. I need to. I think I changed something, so I need to. There we go. So let's run the tester again, and then we'll go straight to there. Okay, what am I looking at? So we created a. Is this what it's supposed to look like? Oh, probably. Let's see. How do we orbit?
You're not sharing the figure, just the code.
I might need to do this then. Screen. Okay. That is not what it's supposed to look like, is it? Or is that just one slice?
It's just one slice taken at a particular y value.
Okay. So let's go down to here.
Oh, did you close the previous figure?
Hold on. Wait, can you see my figure?
Yeah, but I think you closed the previous one, and I think this was supposed to act upon the previously created figure.
because this line of code ran.
And ran all the way to 54, and it was what happened from lines 54 through 60 was supposed to happen on the previously created figure, and so we have to rerun that.
Okay.
There you go.
Okay. So where's our figure 1? Do these look? I thought we were supposed to get like a contour map or something. Oh wait, let's see what the quiver looks like. Or did I need to?
I think it's it just mixing up the figures. Try closing all and rerunning the function.
Okay. So here's figure 1. There's only one figure that appears.
Yeah. Go through the second loop of the 4. That should add the second plot.
And
Oh,
this looks better.
They look very different from one another. I wonder what happened on the first one.
Well, I mean, they're different times, aren't they?
Yeah, they are.
I mean, they're 2 different text files. I guess it makes sense.
All right. I guess the first one started with a uniform. I don't know.
Okay, let me check the chat. Quiver function. Yeah, we can go over that. Someone saw my desktop background. Let's see, quiver function. It's basically a slope field. So there's 4 inputs. So okay, mesh grid. You're gonna see this a lot in terms of when we're doing 3D plotting. But as you can see, there's ways of doing it without the mesh grid function. Henry didn't want to apparently. So this is like your slope. It's kind of like, I guess this doesn't have to be your slope. It doesn't have to be a slope field, but you have a vector at every single point. You're plotting vectors at every single ordered pair. So this is like, oh, if you're at, let's say, x equals 1, then you're going to have a vector that has a x component of 0.25, and then a y coordinate of, let's say your y is also 1, then it's 0.5. So everything on the x-axis is going to have only an x component. Everything on the y-axis, only a y component. And then you have some combination of that in between. Is that an adequate explanation of the quiver function? It's, as far as like how to use it, I mean, the MATLAB documentation is basically that. Basically teaches you how to do that. Okay, let's go back to MATLAB. Okay, so okay, I think that's okay. That's the end. I mean, this is all in the recording, but I mean, let me know if everyone wants to like take a screenshot just right now of like any part of the function that we went over.
Perhaps expand a little bit the code area for line 16, which is the quiver line. It has long inputs.
Can I fit it all?
Very, very long inputs. So probably place an ellipsis somewhere. Oh,
no, I think this is the end. Okay,
that's the end.
Yeah. I was saying hold on, and like right as I say hold on, I was like, oh, the last part's hold on. Yeah, this part's just, it's very long, but it's just, I think if I were to code this, I'd probably split this up into 4 separate lines, like this equals z plot, this equals z plot. Here's the third output. Here's the fourth output.
Yeah, I would have also split it into 4 lines. Just for
And as I reviewed
readability.
it, sorry, just as a review, hold on is just you make a plot, and then you hold on is like you don't want to overwrite the previous one. So if you want to put, let's say, to use the analogy of, let's say you want to put a parabola and like a cubic function on the same plot, then you just do plot the first one, the parabola, say, then do hold on, then do plot the cubic. So that's how you put things on the same graph. So if you want to do that without overriding the previous function, that's how you do it. All right, hopefully that answers people's questions. All right, I'm gonna stop sharing this one. We'll go back to 2, I think, and then what was the plan here?
Or in the meanwhile, let's take a few moments to see if there are any questions people want to ask. There's a question. I'm not sure if we went through it. What is the reshape command used for? And does the apostrophe mean transpose? The apostrophe does mean transpose, and the reshape command, what it does is that it takes an input matrix and an input size, and it literally reshapes the matrix into submatrices of the size you specified. So you could use it to turn, I don't know, a square matrix into a column vector, for example, or into a set of like a 3x3 matrix. You could extract the subsets of 2x2 submatrices. That's the kind of thing it does. I don't remember what it was used for in this particular problem. Do you remember, Dennis?
Oh, for 3?
For reshape.
Reshape was to turn the temperature and the temperature, velocity, those column vectors into matrices. So we had like a big old column vector, and then we wanted to kind of slice it up in a way that turns the. So remember how like we had a temperature for all x's, or we had like however many, let's say like 199 x's, and then each of those had like a temperature, and then that's one row, and then for the next value of z, I think, then you would have another row, and that's like 199 more x's, and then we keep going like that.
Oh, that makes sense. Yeah. If you, I hope that answers the question. If you have, like, if you are not sure how to use that specific function, go through the documentation. There are a lot of examples in there, and it helps. That's a function that perhaps you don't use a lot for normal, like, I don't know, you're taking a mechanics class or some kind of engineering class. That's perhaps not the most common function to use, but it is very common for these kind of exercises where you are collating data from a source, and you have to gather the data in whatever shape it was given to you, and you have to reorganize it to be useful to you. So it's very useful. I would call it a research tool rather than a normal school tool. If that makes any sense.
I think we already went over in 3 a lot of what we're gonna do in 2. Because I mean 2 is kind of like a scaffolding for 3. So I don't think we even I think it'd be a waste of time to show the solution to this. We can just show what we do for 1. Just because I mean F open, F get L, F close. We already went over that. And if I can show this, I can do sounding.text and show what that looks like. So similar thing. I mean, here the headers are a lot more user friendly, I'd say. Still a lot of points, but you have the time, you have the pressure. Yeah, pascals. Wait, what's the H? I'm curious. Where is any similar text files?
In the other file, I'm not sure why they call the first line headers, because they're not really headers. They don't correspond to the columns below them. They are just metadata. These are actual headers.
Yeah, but whatever function you write here should work for 3, I think. I don't think it actually uses myGetVar, the whatever was used in 3, but you can use it, to my understanding. Though I'm not sure in the actual PDF. Hold on. Yeah. Do people still want me to go over this one, or is going over 3 enough to kind of handle this one? Because I did kind of get over. Well, Jose and I, mostly Jose, discuss that. If there are no objections, I'm fine going to 1 and then just showing what to do for that one. Then we have the time to do that. We went over this. Oh, I see something. Rather go to 1. All right.
All right.
Yeah, I agree. Yeah. Okay. Here, my annotation marker is still here. Here's the thing. Like the PDF, there's like an annotating in the PDF, and there's annotating in the actual Zoom thing. I mix them up occasionally.
And I cannot say this enough. The annotation tool in the PDF, it detects when you are using a pen. The Zoom annotation tool should do the same.
Okay. Let's go all the way to. All right. Yeah, this is the one I tried out myself before coming here. Where is the solution though? Not myGetVar, my polyplot. Okay, what am I screen sharing right now?
You're on the PDF right now.
All right, let's fix that. Okay. Okay, this is a good idea. Here's the thing. What I did for this one is a little different. I had like markers being like an entire string. Hold on. This is something you can also do, by the way. You don't have to do it this way. You can do like plus O star and then just like have a bunch of other strings in this and then have that. And then you can do markers 1 to get, say, your plus.
Yeah, that's smart. I think I like that way better, actually.
Since they already gave this to us, let's work with what they give us. Okay, so first of all, the markers. We're going to pull some marker out of this for each order that we plot. Order 1, order like this is order 1, order 2, order 3, all the way up to 13. I think they run out of markers actually, which is why they stop at 13. Okay. So Initialize the figure, hold on. You can put the hold on after the plot, but I don't think it matters.
They don't need it there, but it doesn't hurt.
Ones and max. Oh, they're just initializing. Yeah, this is just like a speed thing. Sometimes if you have a like if you have like a y that's changing in size, then I guess it's not like changing in size because you're just creating them here. They're just initializing. That's what they're doing with this one.
Creating it, but even then, it helps for speed because so this is a very simplistic way to look at this, and I don't want to take more than a minute on it because we are running out of time. But when you have your RAM memory, this has some capacity. Let's say it has I don't know, 8 gigabytes of capacity. When you create a variable, it's stored in the RAM because you will probably want to access it quickly. This is the quick access memory of your computer. And if you say that y is of size I don't know, 1 by 3 million, let's say 1 by 3 million, then it allocates some space in the RAM for that variable. And if so, it finds a space in the RAM for that variable and then allocates it. And if you then do something different, if you change a part of this variable, let's say you write, let's say this was only once, and then you write something like the 1053rd element is equal to 3, and you run it, then it overwrites that number, but the whole y variable is still contained within the same physical portion of the memory. If then you actually say y element 3 million plus 1 or n plus 1 equals something, I don't know, 0, then the variable is a little bit bigger and it needs a little bit more memory, and maybe your computer will be able to find that memory quickly, and like maybe there was empty memory. Let me change color. Maybe there was empty memory here, and it just said, okay, now we need some of that empty memory to be part of this block of information. But maybe there was an empty memory, and the empty memory, there's some block of empty memory here, some block here, and it has to find enough empty memory to store the now bigger y, and that takes a while. So creating it before it still helps for speed purposes. Again, this is oversimplistic. It's not that easy, but that's more or less how it works.
Thank you, Zay. A lot of this is still in the PDF. I say that I've been saying that a lot today, but here's one bullet point. Like here's another bullet point. Well, I mean, here's actually plotting it. You'll have, what is this? Here's where you do the color. Here's where you do the markers. And here's making a line. So this is specifying a line, as opposed to, like, you can do like 2 dashes for a dotted line, like this. Line with 2. What is this? Labels. Here's a sprintf. I mean, here's like your format spec. They don't like have a separate thing for that. It's just the number of the order. And that's going to be the labels that we'll eventually use for the legend over here. So here specifying northwest. I'm pretty sure you don't need this equal part. You could just do Y label, X label, and then title. And then here's just them specifying how big you want the text to be.
Oh, they do the Y lab equals this, X lab equals that to use the set function later.
Oh yeah, that's yeah. If you don't have this, I think you can just say like Y label, X label, title.
That is right. And if you can, and I think that you can even change font size within the Y label command by typing the name of the label, the text of the label, comma, font size, comma, the number, the value you want for font size. I think, yeah, I think that is a valid syntax. I might be wrong.
Well, let's just check then. X label.
That is a common syntax for graphic for graphic objects. So that's why I think it's a valid one. But there are a couple of functions that don't take it or take it under certain conditions. So let's check.
Okay, that is how you do it. Let's do, yeah. I actually found the exact part in the documentation. Yeah, X label, label it population, font size 12, font weight bold. Think you guess what that does. And then red. And so we have a red population. In my opinion, it's a bit ugly, but that's the example.
Yeah, it's a little bit ugly. But yeah, that kind of syntax is very common for graphic objects, whether they be labels, the actual plot, the axis. It is very common that these functions will let you type between single quotations the name of a property and then the value of the property.
Do you think you change the font as well? Something other than Courier New?
Yes, there are ways to change that. I have never actually bothered doing it. What I've done to change the appearance of my graphs and my outputs is change the text interpreter to LaTeX and formatting it using LaTeX syntax. There must be other ways to do that, more simple ways.
Oh yeah, you can use the like there's like a latex option here. You can use it using, oh god. I've typed in latex before. For those of you who don't know, latex is like what they use to write stuff that makes it's hard to describe. It's used a lot in like research papers and especially math, where you have like a certain formatting. It's like a, what is it? It's like a language. Okay, it's called a text interpreter, where
It's
you can.
Yes, it's a text interpreter. So it's like writing programmatically or like coding what text are you outputting and how that text will look like. That makes any sense. I can show you an example I can look for one while you go through this.
I'll just Google it. Latex.
Oh yeah.
No, not that latex. Something else. This is what latex looks like. If you see math that looks like this, or
you're still sharing your MATLAB screen.
Oh, yeah. I was looking up latex and it like pulled up like images of. Never mind. Use your imagination. This is latex.
And you can use it to program in quotation marks program how tables will look, like those horizontal lines that are dividing the equations. Those are also programmed in LaTeX.
I find it quite painful, or maybe I'm just not good at it.
It is quite painful. I have never been good at it, but it is also quite useful. So yeah,
it makes you look legit.
It makes you look so legit.
just a semester I was learning how to use Overleaf. To me it's got a terrible user interface, but when you do math using it, it looks amazing.
It does look amazing. And that being said, Overleaf is the best LaTeX resource that I have ever found on the internet. I'm gonna share that resource in case anyone finds it useful. I'll put it in the chat.
I'll go back to that MATLAB in the meantime.
Yeah.
Okay. Raising givens and then plot it. We have 13 minutes left. Open it up to questions so far. This is a weird lab.
It is a weird lab, yes.
It's not coding, it's just following rules and formatting. But it does prepare you a lot for what you can expect if you decide to do research. If you're not interested in research, that's fine too.
This is a very research-oriented lab, yeah. Yeah.
An example I can kind of share, there was one professor I was working with where we were working with like earthquakes, and basically what you see is not atmospheric data, but earthquake data, which is the acceleration of the ground at like infinitesimally like different time intervals, like 1 second and then like a split second later and a split second later. And you can use that to generate, I mean, you guys have seen those, like those big old like squiggly lines that are produced on a seismograph every time like an earthquake hits, like that image you have in your mind when you see like an earthquake, like that is a text file. Shows 1.2. Oh yeah, that's a different one, right? Thanks for the reminder. Which one was that? Surface plot, right?
Yes, it's the surface plot one. Okay, I just sent, just for general reference, a link to Overleaf's tutorials on LaTeX. They are not exactly user friendly, so it's a pain. It's honestly a pain, but if you're ever going to research, it makes you look. I cannot say it in any other way.
This in my view is a simpler, by the way. I think 1.2 is simpler than 1.1, just so that you have your x's, you have your y's, you grid them together, and then you define your two functions, and then the rest is just plotting. And you see here you have your kx and your ky. Here's the subplot syntax you'll see over and over again. 1, 2, which is you have one on the left, one on the right. So imagine like a 1 by 2 array, or just a 2-element array if you prefer. And then the rest of here is just, this is the equivalent of plot in 3D space, surf C. Oh, and then the C means contour. If you just did surf, that would just be like a, instead of a contour, it would just be like a surface.
Like a 3D plot of a surface.
Yeah. Wait, is that?
There are a few other 3D plotting functions that are really useful. I can think of scatter3, which is just a scatter plot, but in 3D. There is just surf. There is, if you ever use MATLAB symbolic math, which I do recommend you look into that for your math classes and in your engineering classes, it's really useful, the symbolic toolbox. If you use that, there is fsurf, which you input a symbolic function that actually looks like f of xy equals, just as you would write it by hand, as you would symbolically write it by hand. You input that and it outputs the surface of that. So there are a few options for plotting on 3D.
trying to, while you're talking about that, move my surface plot. There we go.
.m.
.m, thank you very much. F2, shortcut. I think I learned this like last year with like changing the file extensions. Like you can change it to like .pdf or .whatever, and then it changes how it's read. Maybe everyone else knows that, and I'm just like very dumb. But let's see. What was I doing? Here we go. Run this now that it knows what surface plot is. Whoa. And none of you guys can see it. So let me just figure 1, figure 2, screen. The theme of this lab is it's a pain, but it looks amazing.
Yes, it does.
Here's the surface, and then you can see the contours below it. Think a topographic map, like where it's, you can see the valleys, you can see the peaks, you can see the saddles. I can orbit it. Okay, I completely forgot how to, okay, rotate 3D. It's a Pringle. Fun fact, Pringles are just hyperbolic paraboloids, but you like only take a circular cookie cutter section of it. This is like a square section of that hyperbolic paraboloid. Well, probably not like a. I think it is. I don't know. It's a saddle. It doesn't have to be a hyperbolic paraboloid. Addition makes it a boring surface. Multiplication. Now, I don't think it's hyperbolic. It's sine waves, so that means it's not.
Yeah. So I think the name of this function is harmonic something wave. I forget, but it's a saddle.
Yeah, 53 was a fun time. Also my worst grade at Berkeley. I gotta drop Pringles, which is something I've always wanted to check off my bucket list. My surface. Oh. Now this should be what we do. Run section. With no breakpoint. Okay, this is just, yeah, we finished. That's what it should look like. Something like this. Okay, any questions? We have 5 minutes left. I'm gonna stop the recording.